Welcome to this MAAT Hydro demonstration video. Cursor's motions correspond to mouse motions. Red and green disks correspond to left and right mouse clicks. An IGES file will first be imported from an external 3D NURBS modeler. The dialog box allows initializing the main project data, its name, the fore and aft perpendiculars positions, keel point and design waterline heights, water density, and basic loading data, weight and center of gravity's longitudinal and vertical coordinates. As soon as project data are loaded, they can be selected in the browser or in the 3D viewports. Different display modes are available. Let's select the rendered plus wireframe mode in the viewport menu. Viewports can be zoomed. Viewports can be modified or reframed. Model's faces must demarcate a watertight solid in order to allow it floating virtually. The hydrostatic viewport will therefore only display a red weight curve as long as the imported faces will not be merged into such a solid. Solid menu's mirror surface function will allow associating the imported half hull to its symmetric in order to create such a watertight solid directly. A green curve of areas immediately appears in the hydrostatic viewport, and the ship's complete hydrostatic analysis becomes possible as soon as realistic buoyancy and weight are defined. The created solid is then renamed in the browser. Let's now set a tank in this buoyant solid using the solid menu's cutout tank function. The displayed dialog box allows entering the tank's data, defining its geometry, content, or filling ratio. The created tank appears in the browser. It cannot be seen in the viewports as solid faces are opaque by default. Let's therefore set viewport's shading selector to dimmed in order to make the tanks visible. Let's also notice that tank's liquid load incidence immediately appears on the red weight curve in the hydrostatic viewport. Hydrostatic viewports function allow analyzing the current float in real time. For example, its free trim and immersion function allows calculating ship's longitudinal balance for current load, 3D views being updated in real time, as well as the hydrostatic data. It is now possible to display current features such as current waterline, transverse metacentric radius, freeboard, or tank's free surfaces. The left grid's 6 first fields allow defining the current flotation plane. For example, let us modify heel, trim, and immersion. The right grid's 3 last fields allow you to define an optional swell with a defined amplitude, wavelength, and crest position. As previously, the hydrostatic data are updated in real time. Hydrostatic viewport's reset function resets the current flotation to its default position. In addition to its real-time simulation capabilities, MAAT Hydro provides a complete range of offline calculation tools in the Tools submenu. For example, let us select the transversal stability function. The displayed dialog box allows defining the calculation parameters. The evolution of ship's flotation and hydrostatic data can be followed in real time during stability calculations. The green curve of areas as well as the red weight curve are updated in real time in the hydrostatic viewport. At last, the freeboard and opening lines are highlighted as soon as they are immersed. A result dialog box finally pops up once the calculation is finished. The writing arm curve as well as the calculated data can be previewed using the page tabs. A horizontal scroll bar allows analyzing the ship's behavior in real time within the calculated heel range. Various stability criteria, totally customizable, can be selected by clicking on the Stability Criterion button. Depending on the selected criterion, the curve's heel range can be automatically optimized or manually defined by the user. The displayed results can be more or less copious depending on the selected options. All the displayed results can be immediately exported or printed out. The Retain As button allows retaining the current results within the project file for any further use. At last, the Exit Stability Analysis button allows shutting down the stability results dialog box. The previously retained stability results can then be reviewed on MAAT Hydro's 2D page. Thank you for your interest in MAAT Hydro. For further details, please don't hesitate to download and view the other videos and manuals from our website's resource pages.